Welcome to Train Signal. I'm Ross Bagurtis. This video we're going to tackle switch configuration. Now switch configuration works almost exactly like router configuration works. The big difference here is that in switch configuration we don't have to worry as much about the layer 3 configuration as we do about layer 2 configuration. So my network diagram here of my switch that's currently set up, I have three interfaces that I'm using on the switch, F01, F02, and F03. When we pull a switch out of the box, the primary difference between it and a router is that we can actually pull the switch out of the box, plug it in, plug devices into it, and actually have the switch function perfectly fine. The switch has a base config where all of the interfaces on the switch are up. So the interfaces on a switch we actually call switch ports. All the interfaces on the switch are in the no shutdown state, which means that if we plug a device that is properly configured into it, the interface, the switch port, will come to an up state. All right, so what I've done is I've hooked up three devices here. I have 192.168.10.10, which is my workstation. And then it's the MAC address of my workstation is listed here, 7011248CDC5E. Device 2 here, 192.168.10.11. I've listed its MAC address here. And then the last device, 192.168.10.12, and I've listed its MAC address as well. We're going to find out that beyond the switch ports being in the up state and that the switch is a layer 2 device, the switch configures just like a router does. So the switch, what we're going to look at here, the switch that we're going to look at is something similar to this. Now this is a Catalyst 3750 switch. The switch that I'm configuring is a Catalyst 2950 switch. What the heck's the difference? All these model numbers, 3750, 2950. Well, the model number of the switch tells you its capabilities. The switch that I'm configuring, this Catalyst 2950 switch, is a 24-port switch. Its interfaces can be either 10 megabit or 100 megabit in either half duplex or full duplex configuration. And then I have two additional ports on this particular switch that operate at gigabit Ethernet as well. So 10 megabit, 100 megabit, 1000 megabit, oftentimes called 10, 100,000. This 3750 that you see in the picture here is pretty much the same thing. We have 24-port switch. We have some extra modules here. These are called SFP slots, where we can plug in a laser or another Ethernet port into that. We additionally have some extra ports over here on the far right that we can also plug small form pluggables, those different modular network jacks that we can plug in there. Really, though, the difference is in the capabilities. A 3750 switch is called a layer 3 switch. Now, that term you may have heard before. What the heck is a layer 3 switch? And this is probably the most poorly designed word or designed label for a device that I've ever seen. And it's a great one. A layer 3 switch is a switch that can also do routing. So it's a switch that can do all of the layer 2 stuff at switching, and it can do all the layer 3 stuff at routing. The switch that I'm working on, the Cisco Catalyst 2950, that can only do switching. There is no layer 3 capabilities on that switch at all, with the exception of being able to put an IP address on it so we can configure it via Telnet or SSH. So we're going to connect to it just like the router. We're going to use a straight through cable though this time to connect from our PC to the switch. We're also going to use the rollover cable here for configuration. Now on most switches, the console port is actually on the back of the switch. So we run our rollover cable from our PC to the back of the switch to the console port back there. So we're going to run our Ethernet cable from the NIC of the PC to the fast Ethernet 01 of our switch. And then the rollover cable we're going to connect to the serial port of our PC, and we're going to run that to the console port of the switch. Switches do not have aux ports. And the reason is that switches, unlike routers, are usually located in an area that you can reach them for management relatively easily. So we use that aux port on a router to hook it up to a modem so that when that router is 50 miles away, we don't have to drive out to it to configure it should we lose our connection to that router. Switches, on the other hand, we don't have to worry about that too much because we already have our aux port hooked up to a modem on our router at a remote site. If that's the case, we can get to the router. Hopefully, our network connection is good enough then where we can just connect to the switch over our network connection versus over a console cable. So what I'm getting at here is that in any location where we have a switch that we need to access remotely, there is a really good chance that we also have a router at that location. And on the router, since the router has the aux port, that's where we can hook the modem up to. We don't want to be hooking up a modem to every single switch in our environment. The last roll I had, we had over 500 switches in our environment between 24 and 48 ports each. To hook up an aux port to a modem on each one of those 500 switches would be ridiculously obscene. There would be too many phone numbers to handle, too many modems. So we don't worry about that aux port on the switch. We just have the console port. Let's go through the demonstration. Stop listening to me show you slides and let's actually look at the switch.